Okay, so this next video is about impulse. So we've talked a little bit about impulse, impulse being the change in momentum. And so we calculated it by multiplying F times T. So momentum can be affected by the strength of a force as well as how long that force acts for, and that causes a change in velocity. Okay, and so some examples of this that might be sorry, let's go back over here. Okay, so I really want to highlight some of these examples. So this is an example of a guy getting punched in the face. Okay, so in either case, he's going to experience a change in momentum, okay, or the glove rather will experience a change in momentum going from its momentum mv to 0, and in one case, where I guess this is just kind of like a soft punch, it's a really long amount of time and causes it to be a really small force. In another case, we have a very large force and it happens very quickly. Okay, and so, I mean, if you were this guy, you would prefer this scenario where you experience the smaller force. Okay, in both cases, it's brought to a stop, but in this case, he doesn't get hurt. Okay, the same thing here. We have a truck going from momentum mv to 0. In one case, it hits this pile of hay and it's brought to a stop slowly over a long period of time, meaning it experiences a very small force from the hay. And in this case, it hits a wall, it's going to stop very quickly and experience a very large force as it stops. Okay, and so if you were driving this car, you'd prefer this top situation, but from a change in momentum perspective, they experience the same change. When you break it down the impulse, you see that this is the reason why this car is okay and that one isn't. The last one I want to look at, here we have a cannon being fired, okay? And so if the cannon exerts the same amount of force no matter what the length of the barrel is, if the barrel is longer, the cannonball will exit the cannon with a greater speed. And the reason why is that if the cannonball is in the barrel for longer, that means our amount of time is greater, which means a greater impulse, and so greater change in momentum and greater velocity. So now that we're done here, or now that we've seen those examples rather, I want you to take a minute to think about if you were in a car collision. Okay, so here's steering wheel, here's a dashboard, you're inside of a car, okay, there's the windshield, and here's the person sitting there, okay, wearing their seatbelt, alright, and the car crashes and out comes the airbag, okay? So why, from a momentum and especially from an impulse perspective, do you think that we have an airbag? What does that have to do with impulse, okay? And how does that affect the collision this person experiences? All right, I'm going to give you a minute to think about it and put in your own answer. All right, so anyway, this person, think about what the person experiences if they were just to hit the steering wheel. Okay, they're going from momentum mv to 0, right? At the end they have no momentum, so we're going from mv to 0. And so we experience some change in momentum beforehand when we get there, on our way there. Okay, and this value right here is going to be what causes our momentum to go to 0. Okay, and so this person, if they were just crashing into a steering wheel, if the steering wheel was the object that brought them to stop or to rest, that caused their momentum to go to 0, that would happen really fast because it's a really hard surface. It doesn't give it all. They're going to hit it and they're going to stop immediately. And so they experience a large force over just a really quick time. Okay, and so the goal of an airbag is, in any way, in a collision, anything that you can do to increase the amount of time, then you're doing something to protect this person. Okay, so when they crash into the airbag that shoots out, okay, then that's going to increase the time, which then will decrease the force. Okay, which is what you want to do if you're trying to protect someone, decrease the force that they experience. Okay, and so this is why we have airbags. This is why they pad different parts of the car, okay, because that allows us to increase the total amount of time that the person is experiencing the collision, okay. You'll notice the same thing when you look at the front of a car, okay. If you see a car that gets in a collision, you'll see that the front of the car is designed to crumple. Okay, it's going to crumple a lot because the more that this crumples, the more time the collision is going to take and the safer the person will be. Okay, so I'm going to show another scenario here in which we're going to actually use impulse to solve for some information. So here's an egg, alright, it has a mass, we'll say, of 60 grams. I'm not sure if that's correct for an egg or not, but and let's say it's falling downward at a speed of 10 meters per second, okay, about to hit the ground, okay, with a speed of 10 meters per second. And let's say that the average braking force of an egg is 220 newtons. If it experiences a force of greater than 220 newtons, it's going to break. All right, and so we're going to analyze this from a momentum perspective. Okay, well, before it hits the ground, it's going to have some momentum. Okay, it's got its mass of 60 grams, which would be 0.06 kilograms, and it's got a velocity of 10 meters per second. We'll say that down is positive for this. Okay. And then after, it's going to come to a stop. The ground's going to stop it. So afterwards, it's going to have no momentum. Okay, velocity 0. So we have before our mv, and then after we have our mv. In this case, this is going to be 0 afterwards. This is going to be 0.06 times 10, which would be 0.6 kilogram meters per second. Now these are not the same because the momentum changed, and so we account for that by including force and time. Okay, and so we're actually going to show that on a graph as well. So let's say it experiences some force for some amount of time. Okay, and we want to know if this egg is going to survive. Let's figure out how long this collision has to be. So it's going to be a negative force because it's making it stop, so it's going opposite of the velocity, right? And so it's going to be a force of 220 newtons if we want to protect it 220 or less. So we want to know for how much time does it have to experience that force to be protected. How long does the collision have to last? So we'll say negative 220 newtons times t. Okay, so we subtract that over this guy right here. We get negative 220 newtons times t equals negative 0.6 kilogram meters per second. We'll divide by negative 220 and get a time of 0.0027 seconds. Okay, that's about 2.7 milliseconds. Okay, so if an egg is in a collision that lasts longer than 0.0027 milliseconds, then it will survive. If that collision that the egg experiences lasts less than that time, it will break because it will experience more than this average force. Okay, now, I mean, this would probably be different depending on the eggs, but this would be kind of like an average value. Okay, so here's another example. In this case, we have a baseball. Let's say it's going 30 meters per second to the left here. Let's say it gets hit by a baseball bat. Let's say the collision lasts 0.05 seconds, and then afterwards it's going this way to the right. And so the question is, well, how much force does the bat exert on the baseball? So to start this off, we're going to say that this way to the right is positive. Okay, and we can draw our before and after charts for momentum. Okay, before our baseball with a mass of 0.2 kilograms, and after, okay, before it was going 30 meters per second in the negative direction, so that would be negative 30 meters per second, and then after it's going in the positive direction with 40 meters per second of velocity. Okay, in between, it's going to experience some force over some time. So what I want you to do is go ahead and calculate what the force it experiences is. Okay, So go ahead and calculate it and submit your answer. Okay, so at this point you should have got an answer. The next thing we're going to do is I'm going to work it out for you. Okay, so anyway, we're going to do this calculation now. So we have a mass of 0.2 kilograms and a velocity of -30 meters per second, some unknown force for a time of 0.05 seconds, and then our mass 0.2 kilograms and our final velocity of 40 meters per second. Okay, so we multiply these and we get 0.2 times -30 would be -6 kilogram meters per second. And then on the other side, 0.2 times 40 is going to give us 8 kilogram meters per second. We'll add that to the other side. And this is 14 kilogram meters per second. So we'll divide by the time and get a force of about 280 newtons. Okay? Which means that this baseball experiences a force of 280 newtons for 0.05 seconds. Now, actually, in reality, the collision between the baseball and the bat is more on the order, I think, of 0.0005 seconds, which means that the baseball bat, instead of exerting 280 newtons of force, actually exerts, that would be 28,000 newtons of force. Okay? If it was that time instead of this one. Okay?